Hello, this is Julian, and you are listening to the Obscast.
Sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome to the Obscast, the podcast dedicated to Sherwood Observatory, its members, visitors, and all budding astronomers. This is your December episode featuring a few members of the Obscast team that have been, in one way or another, responsible for bringing you the Obscast throughout 2023, whether that's appearing on episodes or helping in other ways behind the scenes. We are going to be briefly discussing a few of the events from 2023, from spaceflight, space exploration, personal scientific journeys, and new equipment that will help our own society contribute to real science. Here for you today are...
Stephen Binns. Today I'm talking about radio astronomy's 3-metre dish.
Kathryn Wass, and today I'll be talking about a visit I made to the Gran Sasso National Laboratory in Italy.
Hi, I'm Stephen Smith. I write the Looking Up article in the E8, and I'll be talking about what's happening this month.
Hi, I'm Michael Janiczek. I'm going to be talking about today about SpaceX and a little bit of European rover challenge as well.
And I am Joe Gathercole, and I will be talking about OSIRIS-REX. But for now, if we start with Steve and what you've brought in for us today.
Hello there. One of the most exciting things to happen in astronomy for me this year is the 3-metre radio astronomy dish that Sparky's purchased in summer. We haven't had any readings from it yet, but I'm sure it's going to be a massive benefit to the radio astronomy section. The radio antennae was on the Birmingham Tower, a radio tower in Birmingham, and it was used for communications. This was upgraded in 2020 and was no longer required. So a local man who lives in Birmingham said he'd have it. He took it home and he intended to do moon bounce off it. Now, moon bounce is when it hits the moon and comes back and you get data. Now, unfortunately, COVID-19 hit and he was unable to carry on what he wanted to do. So in July of this year, Sparky said, I'll have it then. And so Sparky bought it to the Obs. Now, this was, as I say, it was going to be used for moon bounce, but what Sparky intends to do now is various detections. Because it can have different focals in the same antennae, we can listen to the sun during the day, and with the same antennae we can listen to the hydrogen line at night, where at the moment one antennae is for a different section only. But this one will be able to do multiples. Hopefully we'll be able to listen to pulsars, which is really exciting. We've never ever listened to those before. If you imagine a telescope, the bigger the lens, the further you can see. Well, the bigger the dish, the more you can hear. So hopefully we will be hearing pulsars and variable stars. Now, I think variable stars, well, can you see them? Yes, you can see them. But sometimes you can't. And that is because of the gas that surrounds them. There's gas surrounding each star. When the gas moves, it creates radio waves. The brighter the star, the more energy it creates, therefore creating better sound. We can hear it through that better radio wave, so we can pick it up better. The dimmer the star, the less energy, so we get low readings. So we'll get a fluctuation between high and low readings on variable stars. We've never been able to do this before. Along with listening to the pulsars, we've never done that. So this is why I think this is a really exciting project that Sparky's got. The drive mechanism for this is very, very similar to the 24-inch scope upstairs. Chris Dakin and Sparky has been talking about it, and they've decided that the drive for this is the best for it. So when it's situated up at the top, in the top corner on a concrete platform, the drive will be exactly the same as what drives the telescope, which can't be bad. Also, as the waves go through space, it can detect alcohol and amino acids. Something else we've never done before. Probably only small amounts, but it's there if we can measure it. So that's something else we could measure as well. Also, Sparky's going to put what's called a cantonar on the dish. Now, this is to extend signals. They're on TV aerials, they're on communication aerials. It's to extend the aerial so it can travel further. Now, this will travel a lot further into space and hopefully pick up signals of better clarity. Detections, like I say, it's not fixed for hydrogen line, and the alcohol and amino acids, it'll pick up on the way. Now, there's another thing called MASARS. Now, that stands for microwave amplification by stimulated emissions of radiation. So, don't ask me what that is, because I don't really know. I know Sparky's told me what it is, but it produces electromagnetic waves, which we can also pick up. Now, with the weather we've been having, we've had lots of snow. So we've got to beware when we put this dish in sleep mode, it'll be pointing up to the sky. Now, one of Sparky's colleagues had one of these dishes. It snowed heavy and the antenna collapsed with the weight of the snow. If it's a grid-like dish, it's not too bad, but this one is a solid dish. So the snow will collect in there when it's in sleep mode, i.e. at night, overnight, and it could make it collapse with the heavy snow that we got there. So what Sparky's doing is putting either a tarpaulin over it or some kind of heater. Now, this is way in the future at the moment. We've got the SDC project on. We know where the antenna is going in. It's going in the top left-hand corner. And hopefully within 18 months or after November, we will be able to listen to these pulsars, variable stars. If you're interested in radio astronomy, you can either contact Sparky or me, Steve Binns, any Wednesday night or any time you see me. And that's about the 3 metre dish. Thank you.
Wow, that's amazing. I knew we had the 3 metre dish, but I didn't know what it was capable of doing.
Yeah, it's phenomenal. It doesn't look much, but
it looks like a UFO.
Yeah, it's absolutely very, very powerful. It's like a scope. So you've got a 4-inch scope.
Yeah.
And then if you multiplied that, well, that little antenna for hydrogen line,
yeah,
that is immense.
Yeah.
And it was used by the radio tower in Birmingham for communications. And he's put in, these MASARS and cantenna on it, which extends the. Yeah. It's a lot of work needs to go into it because it's more professional, but it's notching radio astronomy up a lot.
Yeah, and I think we already do quite a lot more than lots of other astronomical societies.
I mean, when I joined, it was that little room there, and all we used to joke, didn't we? Beep, 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 and that's all we could. And we thought that's boring, and now it's gone on to.
He's really expanded the radio side.
What he's doing is unbelievable, and he's trained me a lot on it. And it's really exciting. He phoned me last night to give me a bit of information. I'm doing a piece on EH this month.
Oh, okay. So we have radio telescopes here that are already doing science, and this is going to expand what we can do. And the telescopes we have now are shared with the scientific community and contribute to science. Is this going to be shared into the scientific community to help?
Yeah, this will be. This is aimed more at, not say school children, more at universities, college students, and even radio hams. We've had a group of radio people come up, amateur radio, to look around the RAC, and they fed back to they wrote in their equivalent to EH how good it was. And if you get the chance, come and see it, because they said we've got tons of stuff that would interest radio hams. And I should imagine now we've got the Jupiter IO system that isn't working yet, but Michael's working on that to get that sorted, and we thought that was good, but then the SDC interrupted it, so works stopped, but that was very nearly there. And we thought that was good, so you can hear the sounds, the interaction between Jupiter and Io, the waves that will come back, because it's like a magnet, and it throws out. Jupiter don't like what Io's throwing at it, so it chucks it out into space every direction, and when Earth is in that direction, that's the noise we can pick up from the Jupiter Io system. But this will be a lot greater than that, a lot greater. But it's just
it's
time.
It'll be interesting to see how that develops.
Yeah.
How it's steered and how accurate it is to get onto something.
Yeah, it's very, very interesting. It really is.
Because it's a huge dish. isn't it?
You can probably hear it now on the recording, because I can definitely hear it. There's a banging noise that's coming through on the recording. That is the 3-metre dish outside, tied to the wall. Getting a bit of wind behind it and moving it.
It was at the RAC, wasn't it? But we had to move it for the work.
And it's brilliant. He's managed to get it for free.
Yeah, that's incredible.
And he bought it up as well, the guy from Birmingham.
Really?
Yeah, he transported it also. So I don't know whether he paid for it, but he couldn't do any work on it, the guy.
It's interesting you mentioned university students, because I know the Loughborough University have got their own 3-metre, and they do similar stuff that you were just saying. So there's a new player in town now. Yeah,
he goes and visits some unis and colleges and science places like that. I think he's gone to Nottingham University, something like that. So he gets a lot of help and a lot of assistance from, say, professors down there who teach the students, and he gets assistance from them as well.
Well, that's incredible.
Yeah.
Thank you very much. If we move on to Kathryn.
Yes, so looking back on 2023, there are 2 standout highlights in science and astronomy for me. The main one was becoming a member of the Sherwood Observatory, of course, and the second, a private visit I made to the Gran Sasso National Laboratory in Italy. The laboratory is the largest and most important underground research centre in the world, devoted to neutrino and astroparticle physics. Construction started in 1982, and the cost for the construction of the underground halls was 77 billion lira. It was designed and built with the main purpose to take advantage of the protection from cosmic radiation by over 1,400 metres of mountain overhead. Gran Sasso, or Great Rock, is in the Apennine Mountains. Basically, it's huge, it's underground, and it's incredible. After driving 75 miles west to east from Rome, we drove into a 6-mile tunnel. Quite hidden, there is a side tunnel entrance that crosses under the mountain. After going through the solid-looking doors and security, stopping off to collect our safety helmets, we entered the huge main tunnel connecting the underground structures to the 3 experimental halls. It's a bit of a shock to the system, as it was a lovely sunny 35 degrees outside, but because of the vast amount of water inside the mountain, it was only 6 degrees and the humidity almost 100%. Each of the 3 experimental halls are waterproofed, heated and ventilated. It's hard to imagine that this worldwide structure is used by around 1,100 scientists from over 29 different countries, working on at least 15 experiments at different stages of progress. Scientists there are looking for answers to how the universe began, how do stars work, the nature of neutrinos, and what is dark matter. I can't say that I totally understand the science that is happening there, but what fascinated me the most was dark matter. Unlike normal matter, dark matter does not interact with electromagnetic force. This means it does not absorb, reflect, or emit light, making it extremely hard to spot. In fact, researchers have been able to infer the existence of dark matter only from the gravitational effect it seems to have on visible matter. Dark matter seems to outweigh visible matter roughly 6-1, making up about 27% of the universe. And here's a sobering fact: the matter we know, and that makes up all stars and galaxies, only accounts for 5% of the content of the universe. The CERN Neutrinos to Gran Sasso project aimed to unravel some of the mysteries surrounding neutrinos, light, neutral particles that hardly interact with matter, and from July 2006 to December 2012, muon neutrinos were sent from Switzerland to the underground laboratory 732 kilometres away in Italy. Incredibly, these neutrinos were detected to have easily passed through the rock. It was a real pleasure to get a glimpse of the work being done at the underground laboratory, a window to another world, as curiosity-driven scientists from all over the world are working together to unravel the mysteries of our universe.
Wow, that sounds like an amazing trip.
Excellent. Yeah.
It was fascinating. I absolutely loved it.
I was going to say, what were you doing there?
Well, it is through work, kind of. I've got to know a top scientist in Italy, a very good friend of mine, and I went to stay with her for the weekend, and she surprised me with this visit.
Wow.
And it was amazing.
Yeah.
It really was, were driving along and it was beautiful weather. And then you just stepped into this other world. And it was so space age. And
Cutting edge, isn't it?
it is. The equipment that they'd got in there. And you think, how did they get it in there and set it all up? And I think for me, the technology, the engineering that they've all put together in there.
But that amazes me about neutrinos, that they can go through anything.
Yes.
And you think, well, how can they do that? And it's even through the Earth and through us.
Through us, that's right.
They
fire them from CERN, don't they? You said 700 odd kilometres. They just aim this machine at them, I guess, and fly off.
We were just going to go on a trip there, weren't we? But COVID hit.
Oh, really? Oh, it's such a shame.
It was Kathy was going to sort it, wasn't she? But we never got there.
Yeah. Fascinating.
So what was this lab like in terms of scale? When you walk in, is it kind of a cavernous expanse of areas or small holes with labs built in?
No, well, it was kind of there's the main entrance tunnel, and then you go to the bottom, and then it splits off to 3 independent tunnels, and within those tunnels were the different experiments all set up. And you're talking about huge experiments. There was one experiment where I think they'd frozen these neutrinos in this great big ball, and then they were waiting for it to thaw out so that they could try and detect their movement.
And they've got telescopes under the sea as well, hasn't there?
Oh, all sorts of things
in the
like
ocean,
that.
To try and catch neutrinos
detect
going
these
through the
neutrinos
Earth.
coming through. Yeah.
Baffles me what humans can be capable of.
It does, and it's amazing to think that they had the foresight because it was predominantly a tunnel to get through from west to east, and they thought, what a great opportunity to build an underground laboratory.
Science lab,
yeah.
Sounds like Thunderbirds, doesn't it?
It was just like that.
Swimming pool comes up.
Does anybody remember the faulty sensor incident? There was a news story that they thought a neutrino had travelled faster than the speed of light somehow, and they were trying to figure out how that was ever possible. Obviously, it wasn't. And they were talking about how it may have blasted through into another dimension, taken a shortcut and jumped back, and it turned out to be a faulty sensor. In the end, it was nothing quite. But that was a CERN and Gran Sasso.
I think they will discover we'll probably discover stuff like that in the future that we don't even dream of knowing.
Yeah.
And they've got to, haven't they?
Yeah.
That's their only faux pas, though, I think.
It don't matter with anything.
I know. Won't it be amazing when we actually do discover what it's all about?
You know, there was literally no real science 400 years ago. Telescope were only invented in 1608, you know, and everything, well, mankind has just really thought everything through and discovered mostly everything through checking things out. It's just incredible, really.
The thing that amazed me was I saw a clip of the sky at night from 1960. And there's looking at Mars, and there's trying to work out what vegetation the dark band was. And this was in 1960.
Wow. Yeah.
I was 2. And you think, they still thought vegetation could... Patrick Moore said, I don't think it is. But he's saying, I don't think. There wasn't.
Yes.
They didn't know.
No.
Yeah.
And this is 1960.
As well with Venus, they thought it was full of vegetation.
Under
the clouds.
the
It was a very humid tropical area and that you couldn't see, but... No. Unfortunately, there's no animals creeping around down there.
No.
This is it. This is
fascinating.
The exciting part about human being. We always want to know more, don't we? And just keep...
The passage of time, and you think, did we really think that? You didn't know any better.
No.
You didn't know any better.
No. This is a wonderful part about science.
You mentioned briefly, while speaking, about you joining MSAS this year. That's a society based at Sherwood Observatory. Would you mind describing what your experience as a new member coming in has been like, maybe some highlights of what the society has to offer?
Yes, I'd be happy to, thank you. Well, I've always loved looking up at the moon, the stars and the vastness of space, trying to figure it all out. And my earliest memory was growing up with my brother because he had a Saturn V rocket, which I used to love to take apart and try and find the little astronaut, much to his annoyance. And I got hooked on the Sherwood Observatory after visiting an open evening in October 22. And as has been the case ever since, everyone was so friendly. And I spent ages hogging, I think it was Rob Dawes' telescope, looking at Saturn and the rings. I couldn't leave it alone. It became so real to me. And not just an image in a book or on TV. It was there. It was real. The open evenings are fabulous events. We had a talk. We brought some coffee, cakes. We even bought a hat. Tony set up the main telescope, and we were treated to clear skies and a bright, shining moon. Finishing off, we visited the underground reservoir, which is a lot less underground now than it was. And I can't stress how friendly everyone is and happy to share their knowledge, which is lovely. I then signed up for the basic astronomy courses. I was really nervous at first, hardly knowing anything about space and wondering if I would fit in. But Emma was always there to welcome everyone with a friendly smile, and I thought, yes, I can do this. This is going to be great. So I've attended all the brilliant monthly lectures, either in person or by Zoom, and always look forward to the monthly Event Horizon magazine. It's packed with interesting photos and articles. We get regular emails with information and links. And there's more. As you know, I've joined the book club, reading all sorts of books that I would never have been introduced to, and sharing some lovely meetups with club members, always with plenty of laughs and plenty of food. And I fit in listening to the Obscast on my lunchtime walk. But this is just a snapshot of membership, and I know there's much more that I can join in with when I find the time. There's the weekly Wonderful Wednesdays, the meetups, telescope training, to name but a few. And the building of the new Science Discovery Centre and Planetarium is starting to take great shape. It's so exciting to watch. I can't wait for it to open. Really, joining Sherwood Observatory has been one of the best things I've ever done, and I would recommend joining to anyone interested in finding out more.
Excellent, thank you very much. That's
welcome.
really good. Yeah, it's good to hear as well.
Well,
And,
it's true.
We'll pay you the 50 quid.
Thank you very much. That'll help my Christmas shopping.
Well, thank you very much. This trip sounds amazing. I'm glad you're having fun as a new member.
Thank you. I've learnt a lot. It's been amazing. Loved it.
Excellent.
Thank you.
I'm going to go next with my favourite thing. Well, one of them. It's not really my favourite because I couldn't pick a favourite. There's so many that happened. So I picked something interesting. I picked OSIRIS-REX, which returned a sample of asteroid Bennu to Earth earlier this year. OSIRIS-REX was launched in September 2016, arrived at Bennu in December 2018. After its arrival, it spent nearly 2 years using onboard instruments to map the asteroid's terrain and study its surface, while its operators back home searched for a safe sample collection site. In October 2020, OSIRIS-REX performed a daring touch-and-go manoeuvre, meaning it briefly touched down on the asteroid before rising back into orbit. It collected in its brief touchdown about 250 grams of asteroid regolith, which doesn't sound like a lot, but it's pure asteroid sample, so it's not anything that's had to come through our atmosphere, and it is quite a lot of dirt to bring back from space. It set back off to Earth in 2021, and its sampler arrived safely back on Earth in September 2023, where the samples have been removed and sent off for study. Right now the sample is being studied still, so no answers yet. Nothing's really come out yet. No answers to the questions that were asked have been answered yet. So what are the questions being asked? Well, the answer is hidden in the traditional acronym that NASA likes to give all its missions. Now, OSIRIS-REX stands for Origins, Spectral Interpretation, Resource Identification and Security Regolith Explorer. That's a mouthful, so I'll break it down a bit. The O, Origins. The aim is to study the nature of the regolith, its history, as well as the distribution of minerals throughout the material to gain a better understanding of the asteroid belt itself and solar system. The RI, stands for Resource Identification. This is basically to study the mineralogy and chemistry of the sample, helping to identify its geological history. I also believe, as is indicated by the word resource, they want to know if anything useful is up there in the asteroid belt, although any practical use for that is going to be far in the future. The S is for security. This is NASA checking something called the Yarkovsky effect on the asteroid. The Yarkovsky effect is the change in a trajectory of a rotating asteroid as it's heated up on one side by the sun, then deposits that energy on its opposite side as it rotates around. This energy transfer will be constantly happening as the asteroid is constantly rotating, so it creates a tiny amount of thrust, but as I said, it's constant, so that tiny amount adds up over time. the Yarkovsky effect can be a difficult variable to account for when predicting the orbit of an asteroid far into the future, and Bennu is due to come quite close to Earth late in the 22nd century and could be a risk of impact, slight risk. So it's an interesting object to use and to study the implication of the Yarkovsky effect on asteroids over time. The REX stands for regolith, giving the acronym its RE, and Explorer, plucking the X out of that word to make the acronym work. And this is a simpler topic from my viewpoint anyway, because that's to study the texture and geochemistry of the regolith on the surface. So overall, this year's sample return is the culmination of a mission that launched in 2016. The mission will help scientists investigate how planets formed, how life may have begun, as well as improve our understanding of asteroids that could impact Earth. However, it's not really the end, because the sample has returned in its specially designed capsule, but the rest of the ship is still in space, and just 20 minutes after sending its capsule home, it fired off its engines again, and is now on its way to study another asteroid, Apophis, arriving in the year 2029. Its new mission name is now OSIRIS-REX. It won't be collecting a sample on that mission, though, because it's used that capsule.
Mm-hmm. Wow.
So that's OSIRIS-REX.
Yeah.
And I think the implications of having a sample of an asteroid that has not burnt up on the way or spent hundreds of years
Did I see
on the ground or in the floor.
Something on the TV the other night about part of that. The part of the asteroid is stuck between the nuts and bolts of the capsule, and they can't get it.
Oh, really?
Was that the one?
I didn't hear that.
No, I didn't know.
That was the one, isn't it? Yeah, the nuts, and there's tiny little pieces in the nuts, and they can't get to it, so they've got to take the capsule apart or something.
Oh, okay.
I know. I just.
Have they got the rest of the sample?
Yeah, they've got everything, but except for the little tiny bits that's stuck in the nut, where the nut and in the.
There was a
the
point
nuts.
in the mission after lifting off from the asteroid where they collected too much and they couldn't close.
All right. But they don't want to contaminate it opening the nut.
No,
so they've got to find a way to get it out.
Yeah. Well, as long as they've
It's
got
only a tiny bit, but that
that
could be the
little
bit
amount
that you
can be
want.
sent off to another lab, because they only give off small samples around, I guess.
Yeah.
Keep the biggest one
But
for
this is
themselves.
microscopic bits and bobs near the nut, isn't it?
Yeah.
But they
But
still want
asteroids
it.
usually spend a lot of time sat on the floor, or they find them in the Antarctic, don't they, a lot, because they land on the white and they're easy to see.
Yeah, that's it.
And but they've all come through the atmosphere and they're burnt,
Yeah.
and it changes things. It changes the composition of things inside. So
That one in Gloucester that hit the driveway in Gloucestershire, that was fairly unique because it didn't rain, it wasn't weathered. So the meteor people came
found within
rushing to
hours,
this guy's
wasn't it, as well?
house on
Yeah.
his driveway,
Yeah.
cut all the tarmac up and put it in, laid his drive back. But it was fascinating, that was. It began with W of the village, didn't it? But anyway.
Yeah, I can't remember the name of the village, but I can remember reading articles about it afterwards. But it's like you said, Joe, it's come through the atmosphere. There's oxygen, there's all sorts of things interact with
you
it
don't know what's
straight
come
away.
from Earth. Yeah.
But they were lucky to find samples so quickly. Most meteorites have been on the planet too long, really.
That rings a bell now.
So yeah, pristine sample. They're going to find out a lot. And it's going off now to on its new mission, OSIRIS-REX. So that's my choice.
Fabulous. Yeah.
And lastly, we've got Michael.
All eyes on Michael because he wanted to be last.
Thank you, Steve. I chose for today a little bit of unusual subject because it's about the European Rover Challenge, and which is an international space and robotics event combining competition of Martian rovers and scientific and technological shows. So, going further, as guided by the slogan "We inspire a new generation," we have been brightening the cosmos closer to the general public and making people aware of growing role of modern technologies in our lives since 2014. ERC is also a meeting place for representatives of the European world of science and businesses interested in the use of space and robotic technologies. Among special guests over the years on RECC shows, we had Steve Janiczek former Associate Administrator of NASA, Robert Cabana, NASA Associate Administrator, Robert Zubrin, founder of Mars Society, Harrison Schmitt, NASA astronaut and member of legendary Apollo 17 mission, or Tim Peake, an astronaut of the European Space Agency who ran the London Marathon during his stay on the International Space Centre. The main part of the project is an international robotics competition where academic teams from around the world presented their mobile robot designs, competing in competition based on real ESA and NASA missions. The competition takes place on the world's largest artificial Martian track that is directly derived from the surface of the red planet. Since 2021, the competition is held in both formulas, which is on-site, where the teams compete with self-constructed robots on Mars Yard, situated in Poland, and remote, where the competitors from several continents will remotely control their robot, physically moving along the track located in Poland. Science and new technology enthusiasts attract every year by the ERC. One of the most frequent groups of visitors to our event are parents with children, which is why we arranged the program of attractions to include workshop, interaction shows and speeches for the young ones. The ultimate goal for ERCC is become a standardized test trial and benchmark for planetary activities. So the competition is divided into two separate formulas, on-site one and remote one. In the on-site formula, students teams from all over the world had to prepare a fully functional Mars rover on their designs. The rover has to be a standalone mobile platform. All teams that go through the qualification get to compete on artificial Martian track. The second formula is a remote formula, which all use standardized equipment during the competition, which they will connect remotely via the internet from anywhere on Earth. The winner of the competition will be one of the most reliably prepares the software necessary for the mission and demonstrate effectiveness in team management. In this year, when I look at on the map on the website where it shows how many teams take a part, it was over 140 from different countries all over the world. Mm-hmm. The biggest group was from Europe, and the second biggest group was from Asia, but also from India, quite strong group, and China as well. Yeah, it's quite interesting, especially when you go through the certain groups, you know, and then you're going to check what they're doing and how they develop over the years, because everything they've been doing since the competition started, which was 2014, you can find on the website pictures from each year, loads of explanation why, how and who. And if I remember that right, there is like 20 something different awards for different subjects, so it is a big thing.
Have they chosen any winners yet?
This year, I think the biggest one was the academic group from Poland, from Krakow. I'm not going to be able to translate the name of the of the school into English because it's going to be a hard one. Yeah, and it's quite interesting when you can go through the different years and you can see, especially those group from Asia, when I mentioned like India and China, when they're going up in the competition, you know, every year they in the like top 3. So it looks like in the so-called space race, the Asia is going strong.
Yeah.
Mm-hmm.
So if you interested, you know, in that subject, you can go to the website. It's called roverchallenge.eu, and you can find all the details up there.
Yeah, I don't think I've ever heard of that before, so I'm going to have that right.
No.
And what I think, in my opinion, is very good that attracts a loads of young people. On one of the pictures, I think that was from the last year or year before, I can even see one of those 3D printed rovers we've got here. So yeah, it's...
How far did Chris Dakin get in the competition? He's our resident rover builder.
Yeah, that's a good thing. Yeah.
You're saying, what's Dakin making?
So the second subject for tonight, for me, it is a SpaceX and Starship itself. I think that was something what everyone was waiting for, especially in the second part of the year.
Yeah.
Where the first launch wasn't that successful like everyone thought so. So yeah, second one.
Did it go better?
I think so.
Some people said the first one was a failure, but lots of people said
Failed a bit later.
They got quite far. Yeah.
Yeah.
They're a learning experience.
Exactly.
To put it down
we need to remember that everything what we planning in the future need to go through the learning process. Because Saturn V, it doesn't go just like that to the moon. I think the SpaceX and the Starship itself is doing a lot better than Artemis. Because at the moment, the problem with what SpaceX got, it's all the regulation and law. I don't know nothing about NASA and Artemis 1, but it seems to be they seems to be a little bit behind.
I think the Artemis program's a bit worried about Starship's moon lander that they're planning for 2 years, 2025. I believe Artemis 3 is meant to land on the moon, and it's just going to be a Starship lander. They're worried about that because that's behind. I think everyone's behind in a way, but that's just space travel.
In some sort of way, definitely is a bit behind. But
what about this latest launch? How did the launch pad survive? Did all the engines stay on?
Yes, it was fantastic. Yeah, yeah. If you let me go through all the achievements, what they taken as achievements after this launch is. I'm gonna read it through because that's the statement made by the SpaceX after the launch. The first main subject is all 33 Raptor engines on the Super Heavy booster started up successfully, and for the first time completed a full duration burn during the ascent. Starship execute a successful hot stage separation, powering down all but 3 of the Super Heavy Raptor engines and successfully igniting the 6-second stage Raptor engines before separating the vehicles. Going further, following the separation, the Super Heavy booster successfully completed its flip maneuver and initiated the boost back burn before it experienced a rapid unscheduled disassembly.
Disassembly, yeah, I like that one.
Yeah. Disassembly, yeah.
That doesn't sound like a good thing, but hey ho.
Was it detonated? I heard they detonate it so that they know that it's not going to just crash down on people randomly somewhere.
It lost contact, so it automatically...
Oh, okay. So it was built in...
If certain parts fail, then it's all over. It self-detonates, doesn't it?
That'll calm the astronauts down.
I just can't see.
Yeah.
If this keeps happening, it's just keep going to get destroyed, and I'm sure the money's going to...
Well, they
probably,
make a lot of money on contracts, don't they?
They probably switch that little bit off when they put people in it,
Yeah, I know. Yeah.
So yeah, there is some good things, there is some bad things. What for me is most impressive, if it's coming to the SpaceX and the Starship itself, that they're not giving up. They've got prepared 5 new Starships. They're going through the tests at the moment. Yeah. Another 5 boosters as well. So they are ready.
And they're trying to do something new.
Yes.
On a bigger scale.
Yeah.
And
they planning.
If you look at the footage of the early rockets during NASA space race, there's a lot blowing up before they even lift off the ground. It's just more widely available to watch it fail now, I think. I can just get my phone and go on YouTube and watch a rocket blow up.
I think the good thing about it is SpaceX, they don't expect to have 100% success, but they keep banging away and sending rockets up and learning from it every time, whereas NASA sits back, works it all out on paper for about 10 years, and then they expect better results But SpaceX said just get them up there, and everything that's coming up, they are taking note of it and improving it.
Yeah.
And so I can't fault them, really.
Well, you were saying how SpaceX is kind of held back by restrictive laws, but they do have a benefit as well that it's their rocket to blow up, whereas NASA might have more freedom in trying, but when they blow something up, Congress doesn't like it very much, and it's portrayed as a big failure, probably bigger than Starship, because Starship using investors' money, but their own money, and they're funding it through using their Falcon rockets for other projects. They're taking on lots of contracts and making a lot of money.
The thing is that even the Congress at the moment, they start pushing a little bit more. I mean, maybe not the Congress, the senators start pushing a little bit more in terms of having those flight more often and tests itself more often as well. Because I found out today there was a letter sent to the Federal Aviation Administration in States. Basically, what came from that letter is act now to the Congress itself, because what they're afraid in is that the Republic of China gonna get faster to the moon, or they space agents, than the NASA and SpaceX together. So the senators start pushing the Congress to allowing them fly more often.
Once it becomes more of an official space race rather than kind of what's happening now, they won't want to lose. Once the world's cottoned on, then it's a space race.
Just to sum up everything, if you are interested in SpaceX and what they're going to be doing in a couple of next days, it's going to be quite interesting to see the U.S. military vehicle is going to be going up 10th of December as a payload for Falcon Super Heavy. Is that...
when is that launching?
It's 10th of December, and the name of that suspicious vehicle is X-37B. So if you can check the internet and see how it looks like, it's something unusual, but in the same time, it's quite similar to Space Shuttle. Yeah. Well, a lot smaller. So yeah, that might be interesting. Sunday, the 10th of December. Excellent.
Well, thank you very much. One big event we need to quickly touch on that we can all agree on as a massive highlight. Probably the main highlight, I suspect, for most members of MSAT is the Science Discovery Centre and Planetarium, because this year is the year that ground was broken, and as we can see every time we visit the observatory, work is well underway. As far as I can tell, the build's going well. I don't know anything about building. Looks fine to me. And they're making good progress and still set to open in 2024. I'm trying to sort an episode soon featuring an update on the SDC progress as well as the preservation of the reservoir's historical artefacts. Plenty of other highlights have happened this year in space, including some robotic moon landings. Unfortunately, we don't have enough time to cover everything. So if you want to learn more about those moon landings, I highly recommend an internet search for Chinese, Indian and Russian attempts. A slight spoiler though, one of the big guns in that race tripped at the last hurdle, and while they all made it to the moon, one of them was in bits. Also, the Chinese-built Tiangong space station has taken shape with more modules added this year, and JWST has continued to break records, confuse scientists, which is always a good thing, and create spectacular images throughout the whole year. I highly recommend looking into those topics as well. But for now, we're going to take a quick break, and when we come back, it will be time for the man with his finger on the pulsar of astronomy to give you a tour of the upcoming skies. Steve Look Up Smith will be back with his ever-popular Looking Up section.
Hi there, I'm Steve Smith and I do the monthly Looking Up articles in the EH, mainly to inform members new to astronomy about the many changing objects that come around each month. There's always plenty to see if you are aware of what is currently up there. If an observing opportunity presents itself, be ready and armed with a list of objects that are currently available. Include messier objects such as galaxies, open star clusters, globular clusters and nebulae. Cherry-pick targets from my monthly Looking Up article, or magazines like Astronomy Now, or use an app, etc. The planets and the moon do their own thing, so you would need to have a look what's up there at the time you want to observe. Also, keep your lists somewhere because the deep sky objects will come around at the same time again next year. When you have had an observing session, I found it useful to write an account of the evening, giving details of what you have seen and any remarks that occurred to you whilst observing the objects. It is good to be able to look back on these sessions and share your observations with others too. Please send in a report to the Society's Event Horizon, the magazine, to share with like-minded fellow members. So, what's happening this month? Remember, there's lots more info in the December's Looking Up article. December ushers in midwinter for us here in the Northern Hemisphere. The sun reaches the most southerly part of the ecliptic, the winter solstice, on the 21st of December, with the sun reaching only 15 degrees above the horizon at its highest point of transit. Astronomically dark skies last about 12 hours. Jupiter is a blazing sight all month, dominating the evening sky, whilst dazzling Venus does the same in the morning sky. The constellations Perseus, Cassiopeia, Orion, Auriga, Monoceros and Taurus are just bursting with interesting objects. Look in the EH for more info. The annual Geminids meteor shower are arguably the best and most exciting shower of the year. They peak from around 7 o'clock in the evening on the 14th of December, when anything up to 70 metres per hour may be seen, and the rate should stay high all that evening. There should be a good show this year under a clear sky, with no hindrance from the new moon. The Geminids radiate from an area inside the constellation of Gemini, actually near Castor, and they are usually very well seen from here in the Northern Hemisphere. If you do intend to meteor watch for an hour or so, get comfortable, use a reclining chair, layer up well, and it's nice to have a nice warm drink available too. It's also a good idea to roughly chart any meteors seen on a sheet of paper. Simply draw a small version of Gemini in the middle of the sheet, then quickly draw each meteor showing its direction of travel relative to the radiant. Class the meteors as a 1 to 6 according to their brightness, 1 being the brightest. For example, make the line long and bold if it's a 1, in your opinion, or short and fainter if it's a 6. Count the lines up at the end of the session to see how many you have seen and see if they're mainly emanated from the radiant. The meteor shower's debris originates from the mysterious asteroid Phaethon. I hope you get a few wild meteors on the night. I'll be looking for them. OK, Deep Sky on show this month. At opposition on the ecliptic during most of December is Taurus the Bull. Well, we pretty much covered Taurus last month, so let's look at the surrounding areas to Taurus. Close to Taurus lies Orion with its many delights. For example, M42, the Great Orion Nebula. This is visible to the naked eye as a misty patch in the sword handle of Orion. The handle lies below the 3 stars in Orion's belt. You will need binoculars or a telescope to see this nebulosity in all its glory. With a modest scope and a higher magnification, you can also drill down into the centre of M42 Nebula to further resolve the stars of the trapezium. Have you heard of the trapezium? The most distinct trapezium stars are the brightest 4, and they're grouped together in the centre of the nebula. And they are designated TRAP, short for trapezium, TRAP A, B, C and D in order of right ascension. The trapezium stars are also a good check to compare how good the seeing is on the night, as well as a delight to do each time the opportunity presents itself. So we're looking right in the middle of the nebula, those 4 stars, you can't miss them. Are the 4 stars of the TRAP well defined and sharp? If the seeing conditions are good, I can recommend you attempt to go even further and try to see 2 fainter stars. So we drill down and magnify, and we're looking then for TRAP E and TRAP F that accompany, they're just right next door to the 4 stars. So they accompany the main asterism 4. There's actually about 15 stars in the trapezium, but if you can see 6, you're doing really well. These E and F stars are around magnitude 10, so they're within range. Try increasing the magnification further to resolve E and F so you can actually see it better. And then compare it onto an app and see if those are the 2 stars that are correct. That's the best way of doing it then. You really need to see them. I would love to know if you managed to see Trap E and Trap F. Also in Orion is M78, Messier 78, the brightest reflection nebula in the sky. It is easy to locate. See the chart in the EH. It lies about 3 degrees northeast of Orion's easternmost belt star Alnitak. Visually, M78 is just visible in binoculars under good conditions. Small telescopes show it remarkably well and reveal the 2 illuminating stars, which appear like a double nucleus. Orion's belt star Alnitak lies between 2 famous nebulae, NGC 2024, which is Sharpless 2277, also called, you may know this one, the Flame Nebula. The other nebula is the Horsehead Nebula, IC 434 or Barnard 33. Again, refer to the diagrams in the EH. Of the 2, the Flame Nebula is fainter at +10 magnitude and is about 30 arc minutes in diameter. With a 6 to 10 inch scope and a UHC or oxygen-free filter, this nebula can quite easily be observed. The Flame Nebula is an emission nebula, and its glow is caused by the ultraviolet radiation from nearby's Orion belt star Alnitak, which excites the hydrogen gas of the Flame Nebula, causing it to glow. The famous Horsehead Nebula, IC 434 or Barnard 33, is a dark nebula silhouetted against the glow from the background emission nebula IC 434. The dark nebula resembles the head of a horse, and this has led to it becoming one of the most photographed objects in the night sky. It is also one of the more difficult objects to see visually in an amateur-sized telescope. It requires dark skies with excellent transparency and perhaps the use of an H-beta filter. I have yet to see it. I failed again last year. I must try harder, and I have the H-beta filter ready to go again. Elsewhere, the Rosette Nebula is a vast cloud of dust and gas extending over 1 degree across and covers an area 5 times that of the full moon. The star cluster NGC 2244 lies in the centre of the Rosette Nebula. It shines at magnitude +4.8 and is visible in binoculars. It can be seen quite well in small telescopes, though a medium to large aperture scope. If you use a large to medium aperture scope, parts of the nebula can also be seen too, surrounding it. But use an oxygen-free or UHC filter to see the nebulosity better. Also worth a look in that area is globular cluster M79. The globular cluster, I love clusters. I love globular clusters even more. The globular cluster M79 appears in the constellation Lepus, which lies below Orion. It is a bright globular at magnitude +7.7 with a dense core surrounded by 9.6 minutes diameter halo. Dozens of stars can be resolved across the cluster in an 8-inch scope. It is a beautiful globular at an unusual location in the sky. Most globs are grouped around the galactic centre, but this one is situated on the opposite side of the Milky Way's central bulge, looking out from our solar system. Okay, Deep Sky Challenge this month is the famous Perseus Galaxy Cluster. It used to be called Abell 426. It's now ACO 426. This is the best galaxy cluster available to us in the Northern Hemisphere at this time of year, and it is available to us for most of the night throughout December. Remember, we're not looking at a cluster of stars here, we're looking at a cluster of galaxies. The cluster includes dozens of galaxies and spans around 3 degrees, with its centre situated roughly 2 degrees east of star Algol. This position, there's more details in the EH, but this position gives it the advantage of being circumpolar, therefore never setting from our UK stars. The cluster's dominant member is a giant elliptical galaxy NGC 1275. Its magnitude is plus 11.6. Its close bright neighbour, NGC 1272, magnitude 12.8, should also appear in the same field of view. And if the conditions are good, a dozen fainter smudges may be resolved in your field of view in an 8-inch reflector, 10-inch or above. And those little fuzzies are galaxies, and now you're looking at billions and billions of stars. Again, it would be good to hear from you about any observing sessions you may have had, or we can chat about any of this stuff if you and I are up at the Obs on any wonderful Wednesday evening. So, are you now ready for looking up? This is Steve Smith wishing you all clear skies and lots of wow moments. Thank you for listening.
Thank you, Steve, for another great looking up guide. Thank you to all our guests for this episode, and thank you to all our listeners. Have a great new year, and we will see you in 2024 for another exciting year at Sherwood Observatory.